Hello to our new session to discuss Chapter 7 in Object-Oriented Class with Python. And in this chapter we will discuss lists and tuples, and this is part 1. In this presentation we will discuss sequences, their definition or what they represent, and we will just give a brief introduction about operations on them. Similarly, we will speak about slicing, finding items in lists, and the use of some special operators. So, what is the idea of sequences in Python? Python, similar to other programming languages, has its own sequences. So far, we have covered one of these sequences, namely strings. But strings are actually considered special sequence type in Python. Why? Because they are represented from the same data type. What does it mean? It means we have a sequence of objects, or in this case actually characters, that are connected or bind with one name. So under the same name, let's say a string name, so we have a name as a string, and then we have multiple characters or a number of characters. And in this case, all of them actually represented by the same name, or they are a chain of characters for the same object. However, we have other types of sequences, and the most common ones are actually lists and tuples. And these two differ from only one point. The difference between these two, that lists are mutable and tuples are immutable. That means lists we can change their contents, and tuples we cannot change their contents once they are created. So what are these two, lists and tuples? Actually, lists are collections of objects, you can say, or elements under the same name. So we have an object that holds either objects under it or elements. So it could be of primitive type, like integer or float, for example. It could be also a string. A string, in this case, we consider it also among objects. It could be also a list. But in basic sense, let's say we have a collection of elements, maybe numbers, maybe names, or maybe mixed collection, you can say, mixed between names, numbers, and etc. under the same name. Alright, so this is the idea. How do we represent these items? Simply, we have a formal way for representing or creating a list. A list has a list name, and when we want to initialize it, we need to use the subscript notation, these brackets, and the items inside, or the elements, are separated by commas. So you can have as many elements as you like, or as your problem dictates or requires. And once you're done, you just enclose the bracket. So we have these brackets that allow us to create a list, like this example. This is not the end of it. Now you may just tell me, okay, these are integers. Can we have floating point? We can have. Can we have strings? Yes. Can we have a mixed combination, or can we have combination of all? Yes, like this, for example. We have a string, we have an integer, and we have another string. We could have also a floating point. We could have also a Boolean. It's possible. And this is more flexible than other programming languages in this sense. Right, so what can we do with lists? The first thing we can do is we can print it. We can use the function print to print the list, and this is just as given here in the example, and it will be presented exactly with the brackets, and the way we are formally assigning the elements will be just printed out to the console or to the screen. We have a built-in function called list, and this function can be used to create a list. We can use any function to have a range which will be transferred later on or transformed to another type, which is a list. You remember this range, we used it a lot. It goes from 0 up to 5. Exclusive, 5 will not be included. So 0, 1, 2, 3, 4. And in this case, these integers will be transformed to this kind of scenario or style, or you can say data type. So this is possible and it's widely available in applications. We can do such, you can say, implementation when needed. We will see in practical, we will have some examples to use the, or to define the use of list as a built-in function. All right, we explain about those. Actually, it could be a list of even numbers, list of names, list of mixed, maybe a name and identity, maybe some salary or whatever. We explain about those, no need to just give more time to them. All right, we have something we call a repetition operator. Repetition operator is a special, you can say, operator to lists. If we have a list, any type of list, and we multiply it by an integer number, actually this is not exactly multiplication, I said multiplied as an indication of this asterisk. It's actually the repetition of the string. That means if we apply this kind of operation, we will duplicate, or actually not exactly duplicate, we will repeat the list number of times. So when we have like a list with one element, it's possible, just for the record, it's possible to have a list with one element or a list with no element at all. It's possible, an empty list. So if we have one element and multiply it by 5, it will be repeated 5 times. So we will have a new list, and this list is composed of 5 elements, all of them with the same value here, with the same element 0. And this is what it means, the repetition operator. We may have another type. Let's say 1, 3, 5. If we multiply it, or actually this is not exactly multiplication again, I keep saying because I'm just used to the asterisk notation. It's the repetition. If we want to repeat it, we can compose a new list as follows: 1, 3, 5, 1, 3, 5, 1, 3, 5. That means it will be repeated 3 times under a new list. Actually, we are just changing this one. It's not exactly new, but it's like an updated form of it. All right. Can we iterate over a list? It's possible, and it's widely available in practical programming. So we can use a list to iterate over the items or the elements of the list. That means as long as the list has element, the loop will iterate. So from where we start? We start from the first element until the last element, and this will present for us all the elements of the list, like what we have here. For example, if we have element 0, 1, 2, 3, 4, like list 1, I presented it earlier, it will be just displayed as follows, or the way you see it, because we specified that the end should be just a small space or one space between these elements, not a new line. All right, indexing. So how can we know actually which element is which? What determines that this is the first element, this is the second element, and so on? It's something we call index. So we have an index which is an offset from the beginning, determines, or from the end. So it determines where the location of the element is, or its offset, in other words. Here we have an index starting by 0 for the first element, and then the offset increments by 1 integer each time. So the first element in a list is indexed by 0, the second element 1, third element 2, and you keep moving. Last element is the size of the list minus 1. That means the size less than the size by 1. That is how we index elements in a list. We can iterate over a list using while loop or for loop. It's possible, both of them. And we can present the index and the item. And you can just see like this. We have the list 1 we used it earlier, it was 0, 1, 2, 3, 4. So we can iterate and display the index along with the item. Now they are matching. It's not necessarily. Maybe the items are, are different, not just 0, 1, 2, 3, 4. So that's a possible scenario or a case. Right. I said earlier we can reference indexing, or we can manipulate lists or use or retrieve their elements using indexing from the end of the list. And in this case we can use negative indexes, and it will get us the index backward from the end of the list. Now look at this. If we initialize an index to -1, and let's say we start by the size 0, if we iterate over the list, I'll explain about the length. Len is the size of the list. As long as the size is not reached, if we iterate here, we can get all the elements of the list, and the presentation here will be from the end to the beginning. So index -1 is representing the last element, -2 is representing the one before the last, and so on. So this is a bit unique to Python. You do not usually have such a thing in other programming languages. Right, the length function, as I just explained a minute ago, len, L-E-N, allows the user or the programmer to test or inspect the length of the array, the list. We do not call it array, we call it in other programming languages. We call in Python list. Actually, we do not have exact array definition in Python. We have list, which is actually more versatile than the normal arrays. Right, okay, so we may get stuck with some exceptions if we try to locate an index beyond the size of list, or actually which doesn't exist, because the size of the list is not possible, or is not a valid index. So how can we determine until where or until which index we can go? Actually, we can go until the size -1. Who determines the size, or how can we determine the size of the list? So it is simple. We can use this built-in function that determines to us the size, and size -1 determines the last index. And this is a common exception, you can say, that can be raised if we use a wrong index. And we will actually have some practical programming with some index errors in there, or exceptions, so that we can handle them. All right, so I said earlier lists are mutable. That means we can change their contents. In this case, we can say, let's say, list somewhere, list 1, let's say, list by itself. List is actually a keyword, is used for creating a list. We better not use it without giving any other, like, let's say, list 1, list of items, list of nums, maybe. That would be much better. However, if you use it, it would work. I wouldn't recommend using it without having, like, as I said, little bit slight modification of this keyword. In this case, we can use certain index and change its value, or assign new value to it. That's possible. However, make sure that you use a valid index. Do not go beyond the possible indexes of the list. Concatenation. We can concatenate lists simply by just applying the addition operator, plus sign, and that will concatenate lists. That means these two lists will be combined together, like 1, 3 and 5, 7. They'll be combined together. These are the odd numbers from 1 to 3. Here from 5 to 7, we can combine them, so it would be the list of odd numbers from 1 to 7. All right, we can use also the augmented assignment. This is possible. It depends on your application. Slicing. Slicing is extremely useful application where we can take a span of certain, you can say, indices or indexes from the list, where we determine the starting point and the end point. However, the end itself is not included. So starting point is included in the slicing or the span. However, the end is not. Before the end by 1 will be included. Like this example, look. Earlier we had our list 1, 0, 1, 2, 3, 4. So if we try to slice from index 1, that's 0 is index 0, 1 is index 1, 2 is index 2, 3 is index 3 until 3. So it will be 1, 2 only. Okay. So this is a possible slicing type. We may also skip one of these to start and end. If you drop start, it will start from 0. So the beginning will be index 0. So from wherever it is 0 until index 2 inclusive. If you drop the last end, the last, you can say, pointer or the last location of the slicing, the end, in this case, it will take from wherever we start until the end of the list. In this case, we are starting from index 2, so 0, 1, 2 from 2 until the end of the list, 2, 3, 4. We may also use or apply negative indexes, and that's possible. It will start assigning or creating the span from backward from the end of the list. Let's say list 1 minus 1 start from minus 1. That means start from the last element, and that's the only thing you can take. Let's say we take minus 4. That means take 4 elements starting counting from the last element. We do not present the last element first. No, rather we count just 4 elements starting from the last. So that means 1, 2, 3, 4. That's my list. Okay. Let's say I would like to find an element in the array. So if we want to find this element, we can use a convenient function to do so. I can use the item, an item, no matter what it is, it could be of anything, in the list. If it is available in the list, it will return to us true. It will return to us Boolean value. If it is not there, if it's not available, it will return to us false. So we can use this kind of scenario for functions like, user defined function. It has different types of applications where we can inspect an item, whether it is available in the list or not. Look at this. We are trying to locate whether 2 is available in list 1 or not. It's available because we defined it earlier, 0, 1, 2, 3, 4. And that will return to us true. So the printout here will be true. If we are trying to locate 2, whether it is as a string, whether it is available in list 1 or not, it is not, and that's why we will get an output false in this case. We can use not in, and it works in the opposite way of in, so it's exactly the opposite of in. So let's say we are looking for 2 as a string, not in list 1, that's true, it's not, so in this case it will return for us, or it will return to the calling function true as an outcome. Okay, that's enough for this session, and I hope you will benefit from it. Enjoy your time. Goodbye.